Hello, everybody. Welcome back to another Weather Central forecast. Be having a fantastic day. Now, so today we're kind of switching things up a little bit. I'm going to be starting a series called Weather School Wednesday. So this is hopefully going to, inform you guys a little bit more about what actually goes on when I'm forecasting and what parameters and slash ingredients I use to depict what I believe is going to happen and why. But today we're just going to be focusing on more of the basic tornadic ingredients. I'll be teaching you guys how to go over a SKU-T sounding and just a sounding in general, and we're also going to correlate this to Thursday's severe weather event, so tomorrow. So it's kind of like a 2-in-1 forecast slash informational video. And our target area that we're going to be watching, taking a look at the NAM3K on this forecast today, which they do overestimate the low level jet a little bit sometimes. So it's going to be really hard to depict exactly what's going to happen, but we're going to be looking at a sounding later on. This is not the sounding. This is just one that I found off the internet. But like I said, we're going to be correlating this to tomorrow's severe weather event over here while I'm informing you guys on this so that, we're doing a 2-in-1 here. So our first ingredient that we're going to need for tornadoes here is storm relative helicity. Now, this is measured in meters squared per second squared, as you guys can see right down there. It's the measure of potential for an updraft within a right-moving supercell. Generally, there's not a clear amount of storm relative helicity that you need for tornadic supercells, but I've done some research myself, and what I've seen correlated to past tornadic experiences for your surface to 1 kilometer range, which is 0 feet, otherwise known as your surface level, all the way up to 3,280 feet. Your storm relative helicity values need to usually be above 100 meters squared per second squared. It is correlated, like I've said, to tornadoes in the past. However, you could get the job done with less than 100 meters squared per second squared of storm relative helicity, just depending on your environment and how much other parameters you have to really balance it out, I guess I could say. But generally, if you're going over soundings and just looking at your environment in general, good SRH values for your surface to 1 kilometer range is usually 100 plus. Like I said, under 100 could get the job done sometimes, but that's a good rule of thumb for me whenever I'm depicting where and when I think tornadoes could occur. For the 1 to 3 kilometer range, which is 3,280 feet all the way up to 9,842 feet, good storm relative helicity values of 250 meters squared per second squared plus is more correlated to tornadoes, and that's higher up in the atmosphere, right? So let's say our 0 kilometers right here, right? Our 1's here, and then say this is our 3. What we're looking at here is this was our surface to 1 kilometer storm relative helicity, right? So this is our surface down here. What this is taking a look at the 3 kilometer range is higher up into the atmosphere. So obviously there's going to be a lot more storm relative helicity higher up into the upper levels, as obviously you guys know, the higher you are on mountains, it's going to be a lot windier. That's just how it is. So that just gives you guys a better idea. Now, this is one of the most common thunderstorm ingredients, severe weather ingredients, however, just convective ingredients. Everybody, you guys have heard me talk about this a lot. This is CAPE, which is convective available potential energy. It is measured in joules per kilogram. Like I said, you guys have heard me talk about this many different times. Actually, I do want to go back real quick to our storm relative helicity, because I did forget to mention we're correlating this to tomorrow's severe weather event, right? So this is our 0 to 1 kilometer range for storm relative helicity. And like I said, our target area is somewhere around here. Now, later in the sounding, you'll see we do have an excess of 100 meters squared per second squared of storm relative helicity for, let's see what that would be, around East Central Virginia. I'm sorry if I'm missing a big city that's around there. I'm just not too familiar with Virginia. Going into our 0 to 3 kilometer range, you're just exceeding 200, maybe isolated areas of 250. So our 1 to 3 kilometer range isn't the best. However, it's still exceeding 200 meters squared per second squared. So I'd still give that an 8 out of 10 in terms of how conducive it could be for tornadoes. So definitely don't think that storm relative helicity is lacking in this event. It's just not where I would typically want to see if I was, trying to say that this would be a for sure tornado day. So I'd probably give this a 2 or a 5% chance in terms of how the SPC issues, their probabilities, I would give it a 2% to maybe a 5% in terms of tornadoes for our storm Felicity there. Now going into, like I said, CAPE measured in joules per kilogram, it is the measure of amount of energy available for convection, which is thunderstorms. It is directly related to maximum potential vertical wind speed within a storm's updraft. So vertical, if you guys have ever heard about, I guess I should say, like in sports, people are trying to measure their vertical, which is how high they can jump up in the air and how high their feet can get above the ground, right? So when we're talking about vertical, we're talking about up and down. So it's directly related to the maximum potential of up and down wind speed within a storm's updraft. So obviously our updraft does look something like this. So it is going vertical. More CAPE equals stronger thunderstorms, as that should be known. Any ingredient that I'm going to say in this video, the more you have of it, the better your environment's going to support for tornadoes, obviously. An excess of 1,000 joules per kilogram is more than enough for isolated supercellular development, depending on your other parameters. Now, I forgot to put that in this slideshow, but sometimes you do have a very high CAPE event compared to everything, and your highest CAPE value is only 1,000 joules per kilogram. So if you only have, let's say, 50 meters squared per second squared of storm Felicity and your 1 to 3 kilometer range, you're not going to be seeing tornadic development. But if every other ingredient lines up, you can still get away with 1,000 joules per kilogram of CAPE. But that is only if the other ingredients do offset and help, the lack of CAPE there. But however, in my opinion, this is just in my opinion, 2,000 plus joules per kilogram is really what you want for a good severe weather event, which either depending on if you want this event to get bad for your area or not, which I'm assuming that most of you don't unless you're a storm chaser. I mean, we are seeing an excess of 2,000 joules per kilogram of CAPE within our target area, which is, like I said, around here, just north of Virginia Beach there. You can still see a very wide range of surface-based CAPE there, so that will allow for convection to develop. However, our more tornadic risk for tomorrow, though, is somewhere around here. I really haven't taken a very, very close look because I have been working on this weather school episode today, but right now our CAPE is looking good as well, so we'll give our CAPE a check mark for tomorrow as well. Now, our next ingredient is wind shear, or just shear in general, which is obviously in weather. When we're talking about shear, we're talking about wind shear, otherwise known as bulk shear on those weather models. It is the difference of wind speed and direction over different levels in the atmosphere. So when I'm talking about soundings, it's usually referred to for vertical wind shear, which is up and down, like I mentioned. For CAPE, when we are correlating CAPE directly to the potential maximum wind speed vertically. Whenever I'm looking at soundings, and I'll show you guys this later, I do talk about wind veering with height. Now, that is a very, I guess I should say, crucial part to tornadic development. So let's say our wind barbs look like this, going up into the upper levels, right? So this is our surface down here. Our wind barbs here will start to even itself out. Not exactly like that. I'm probably doing a very bad explanation, but I will show you guys on our sounding, which is after our next perimeter, wind veering with height. Now, that is a very big, crucial part to tornadic development. Usually for the surface to 1 kilometer range, 25 to 30 knots is a good rule of thumb. However, less than 25 knots of shear has the potential to produce brief tornadoes and even could sustain a tornado for a little bit longer, depending on other parameters. I want to say that a lot, but it really just depends on other parameters within the system. You can't just look at one parameter and say, yes, it's going to be a tornado outbreak. Yes, there's going to be tornadoes. You have to take a look at the other parameters. For the 1 to 3 kilometer range, typically 30 to 40 knots of shear is relatively more productive for tornadic development. However, like I said, depending on the environment, less than 30 knots within the 1 to 3 kilometer range can work. However, as for every other parameter as well, the more you have of that perimeter, the more conducive it will be for tornadic development and just strong thunderstorms in general. So looking at our target area tomorrow, you can see shear is not, this is the 0 to 6 kilometer range, so it's a very wide range of wind shear because the model that I'm looking at did not have the 0 to 1 kilometer range and then the 1 to 3, so we are looking, like I said, at the 0 to 6, so you can't really take this too seriously for exactly one part of the atmosphere, but shear is still there. I mean, we're talking about, let's see here. I can't really read these down at the bottom, and I don't believe you guys can either. But I'd say it's relatively around 30 to 40 knots over our 0 to 6 kilometer range. So I'd give it both of them for wind shear there. However, we will be going over the sounding, and it will give us an exact measure of our wind shear within every single level of the atmosphere. So we will be able to take a better look at that into the sounding. And our last parameter here, which is not, I guess I should say, it's not exactly for tornadic development, but I'll talk about this in just a second. It is our lapse rates, and it says it is measured in centimeters per kilometer, or sorry, Celsius per kilometer, because we are talking about temperature here. Lapse rates are the average rate at which a temperature changes with height. So let's say, our over a couple 1,000 feet, our average change is 6.6 Celsius per kilometer. That's going to be somewhat supportive for hail, smaller hail though. Higher lapse rates support larger hail, as that should be known. And hail is typically correlated to supercells. Not always. I should not have put that in there, but as you guys know, with a, let me go ahead and try to draw a quick diagram of a supercell. Obviously, there is a nasty hail core within the supercell around here. Sometimes it can't even be pushed off a little farther eastward. But as you guys know, if you guys have seen Reed-Timmer Chase on his Discovery show, Storm Chasers, you guys will know, and if you guys even watch his YouTube channel now, anytime he goes out and chases these giant supercells, he always gets some sort of damage to his car, which is the Dominator. So hail is a correlation to supercells. However, hail is not the only supercells is not the only correlation to hail. Obviously, our lapse rates determines whether we're going to have hail or not. So, I mean, you can disregard this a little bit, but still, large hail is very, very common within large, powerful supercells. Values less than 5.5 to 6 degrees Celsius per kilometer represent stable conditions as to not much hail development. But values between 7 and 10 degrees Celsius per kilometer shows very, very unstable conditions and very large hail possible. Now, in my time of forecasting, I've not seen it get up to 10 yet. I've seen it get up to the 9s, maybe 9.5 in some levels, but I have not seen it get to that 10 range there. However, it might have happened before, and I bet it has. I just have not remembered from my forecasting experience it get up that high. But generally, in our large hail producing events, we get anywhere from 7 to 9 centimeters per kilometer, and that does show unstable conditions. For our temperature change with height, our average temperature change with height, so that does support that large hail. Now, here we are with our last part of this video. I'm not really too sure how long this is. Okay, so we are at 13 minutes. I thought that this video was going to be a lot shorter, so I am glad that it is lasting us quite a long time, so that there's a lot more information that is getting shown out here. So first thing we're going to look at here, at least what I look at, is the hodograph. Now, hodograph, you want a curvature to your hodograph, and that does support tornadoes. So you can see we have a decent curvature within the hodograph here. Nothing, I mean, I guess I should say crazy. Definitely, though, the hodograph does look to be semi-supportive for tornadoes. Now, you can really disregard this because that is just the potential hazard type. But, I mean, sometimes I do look at that, but that is not at all a good way to determine whether you're going to have a tornado or not. Down here, also, I would not take a very close look at this. This is just comparing the present conditions in this sounding to past occurrences of supercells and hail. So you can really disregard that too. So what we're looking at here is one thing that I also look at is our temperature and dew point here. So our temperature, you guys can't really see, is 72 towards the surface here. So we have 72 degree surface temperatures and 70 degree dew points. Now, what that does is when you have a higher dew point and it's almost the same temperature as your actual surface temperature, your CAPE really decreases and it stabilizes a lot more. Now, what we also see here, like I said, from wind shear, we are seeing a lot of wind veering with height here. As you guys can see, our wind barbs, look relatively the same most levels in the upper levels, but then as we get farther down, you can see they take a turn like this. So that is a lot of wind veering with height here. So I would give that a check mark as well. Now, CAPE is relatively limited here. However, we're going to be looking at more parameters for this to see if this will work. However, I'd say CAPE is not really great for this event, specifically in the area that I took the sounding. Now, as we saw in the slideshow, there was areas in this risk for tomorrow that did exceed 2,000 joules per kilogram. So in those areas, you guys won't have a problem seeing very strong thunderstorms. But for this area that I did take the sounding, which was around central Virginia, CAPE is not very plentiful there. However, our K index is around 35, so we are going to be seeing convection most likely. It'll be a lot more scattered, and maybe some numerous convection, scattered throughout an area. What we're seeing here for our Storm Felicity is very great surface to 1 kilometer range, but our surface to 3 kilometer range actually is still relatively very, very nice. I'd give a Storm Felicity a check mark on that. Our shear, it's nothing crazy. It definitely, though, is supportive enough as well. So I would give our shear a very good check mark as well. So generally, not too bad. We have a very low LCL as well. And our lifted index here, I didn't really go over that too much, but that is just showing how unstable the atmosphere is. And our lifted index of 4 is just showing a stable, or an unstable condition. Nothing crazy. Obviously, because our CAPE is a lot more limited. So I'd give this a check mark and an X. I mean, it's supportive, but it's not crazy supportive. And obviously, we can take a look at our composite tools. You don't really want to use that at all. That is a composite tool, but if you want to, you can see your supercell composite at 9.1. Your significant tornado perimeter of 1.8. Your fixed version is 1.2 there. Our lapse rate's not crazy, not a very large hail producer within central Virginia. However, I guess you could, if these lapse rates do trend up, maybe you could see some pea-sized hail, very, very small hail, nothing crazy. Your lapse rates are relatively stable there. So this just gives you a better understanding of how to read a sounding here. So this is, like I said, the first episode of my weather school. Let me guys know how you guys enjoyed this today, and if I should continue this would be a weekly episode where I would be doing it every single Wednesday. And I would try to correlate it to a severe weather event, or just a weather event in general that is going to be occurring within the near future, so that it can help you guys both learn a little bit more about weather and also inform you guys a little bit on what you could be seeing. So thank you guys so much for watching this video. I hope you guys have a fantastic day, and I'll see you guys in the next one.